welcome to my YouTube channel, guys. Today I am going to make a new video, so please
So a couple months ago, I was watching Mr. Beast, and then I realized. So in this video, I'm gonna make a submarine for Mr. Beast. Mr. Beast, hit me up. So here's the basic idea. I'm gonna build an ESP32 base receiver and controller. The controller is gonna have two analog sticks. It's gonna have a rechargeable battery, rocker switch to turn it on and off, and a couple other buttons to control different things on the submarine. The receiver is just gonna have the ESP32 and the motor modules, nothing too crazy. But then once I'm done with everything, I'm gonna go to my pool or like a lake and I'm gonna test the submarine. So right now I have no idea how I'm gonna code it or how I'm gonna do anything or how I'm gonna make it waterproof, but I'm gonna figure it out. So obviously, I have to draw the fishies to make it look realistic in the ocean. But yeah, so this is gonna how it's gonna look. And then when I start connecting the ESP32s to each other, it's gonna start sending signals like this, and the submarine will move forward. And then when I press buttons, things will happen. Like for example, the submarine will start going down. The first thing I built was the RC remote. To be honest, I had no idea what I was doing, and I did not design it beforehand. I just kind of winged it. And it worked pretty well, so that's good for me. This is the main board. It has two analog sticks, an ESP32, 4 buttons, and a potentiometer. And I took some measurements of the height, width, and length. Then I 3D designed the RC case for it, and here it is. It came out pretty well. Here it is as well. Then I started coding it. I had to code the receiver and the RC remote. Then I connected all the wires and I tested it, and it actually worked really well, so I was really glad about that. So you guys might be asking, did I really build a receiver on first try? No, it actually took me 3 different tries to make the good receiver. 3 different receivers that I built. One super small, one like this big, and then my final one that I'm about to show. Alright, I'm gonna show you guys how I built the first 2 receivers. So I took a perforated board, some male pins, 4 terminal blocks, and 2 L293Ds. Those are the only things you need to make this receiver. Once I finished getting all the components, I soldered it all onto the board, and this is what it looked like. I tested it and it worked, and here it is working. To be honest, this receiver was really bad. It just had 2 L298 ends and then 2 mini L298 ends, some perforated board, and also the ESP32. Alright, since I didn't show you guys how I built this, I'm just gonna run it down with you really quickly. So for the main board itself, it just has a couple female pins connected to hold the 2 L298N minis, and then 1 L293D. The L298 minis and L293D are motor modules, if you guys are wondering, and the main microcontroller is just an ESP32. So here's the basic assembly. So just make sure you solder everything onto the perforated board, obviously. So the main assembly is you just put the ESP32 onto its little stand area, and the way these pins work is that there's a little, it's like a breadboard. There's metal inside the plastic, the black plastic, so that it just conducts electricity through it. So then you could connect everything through the bottom. So ESP32 goes right here. L298N goes over here. When you are designing this circuit board, the design, make sure that when you design it like with the L293D facing the right way, because say you want to use you want to control the speed of the motors connected to the L293D. There's only one side that has the enable pin and the other side is the power pin, so you have to make sure of that. Unless you're not going to use that and you're not going to be changing the speed of the motor and you're just going to have it running, you don't have to do that, because you could use the EN enable pin as a power pin as well. So for this, I just connected the positive and negative terminals to each other, so it's easier to power them. And then you just attach them onto the board. I first originally wanted to not have these female pins, but then I thought about it, and I have destroyed so many different components of mine multiple times because I powered them wrong. That's why I also added this terminal block, because I'm going to label the terminal block. One side is for the positive, one side is for the negative. For example, my last motor controller, can't even, right here. My last motor controller, here it is. I had to strip it for parts. These two motor modules, these L293Ds, exploded, and I almost started an electrical fire in my room. The crazy thing, I was asleep. My friends were having a sleepover, and they were both sleeping while I was working on it, and they woke up because they both smelled the fire, which was kind of weird. So yeah, so make sure you always power right, or it's gonna explode. This is a main example of that. So that's why I added these terminal blocks, so I can know where I'm connecting them. And yeah, this is the receiver. I like how it looks. It looks pretty cool. So yeah. Now, since I showed you guys how I built my receivers, I'll show you guys how I built my engine. Alright, so now I'm going to show you guys how I built my engine. This was the original design. I have no idea why I designed it like this, because it was literally a 1-to-1 ratio. So I was being dumb. But then I changed it up a bit, and it worked even better at the end. So here it is working even better. So the gear ratio for this one was actually 1-to-8. And according to Google, the average 755 motor spins around about 12,000 rotations per minute. So that's about 200 rotations per second. So if it's a 1-to-8 ratio, that means the propeller is going to be spinning at a speed of 600, what the hell? 1,600 rotations per minute, which is absolutely insane. And you can see in this video here, the main gear is spinning quick and the gears attached to the motor are spinning slowly.